So hello everybody, and welcome to today's webinar from MBS, Information Exchanges and the RIBA Plan of Work 2020. So the webinar will last a little bit over 45 minutes. Everybody on the webinar today has their microphones muted, but you can ask any questions in the question boxes on the screen and we'll follow those up after the session. If you do feel that you want to contribute to the debate on social media, then by all means use the hashtag NBS webinar. So this is the 6th or 7th webinar in the RIBA Plan of Work series, where we've looked at some of the key strategies and also some of the key taskbars on the RIBA Plan of Work. And today we'll be looking at the information exchanges taskbar. And they're the sort of key deliveries that support all of the project strategies and getting that outcome that everybody working on a project wants. My name is Stephen Hamill. I'm Innovation Director at MBS, and joining me today is Mike Riley, Architect Associate at BDP, and we also have my colleague Chris Vickers, a Technical Specialist at MBS. So what we'll cover today, firstly we'll have a presentation from Mike, looking at the information exchanges and the RIBA Plan of Work 2020 from a point of view of how BDP approach projects. Then we'll have a presentation of Chris Vickers, who will talk a little bit about what we do at MBS and the information structures that we provide to support the industry. And then we'll finish off with a few little questions and answers where I'll ask Mike and Chris a few questions, and then I'll wrap up. So over to you, Mike.
Hello everyone, and thank you, Stephen. It's really nice to be invited to do this webinar with you all. So as you've already said, I'm going to talk a bit through the information exchanges and the RIBA Plan of Work, and I'm going to actually do it from the sort of architect's perspective. I am an architect, and for the last probably decade or so, I've been working in BIM environments. So it's a sort of lessons learned as much as anything else, as a reflection on what we're doing currently. So here's the RIBA Plan of Work 2020. Which is, I think, a welcome improvement on the 2013 version, which was published a few years ago. And we're going to focus today on the information exchanges. So again, like I was saying, this is an architect's perspective more than anything else. And I think as an industry, we've generally moved really well over the last decade from 2 to 3D models. And now we've sort of matured that sort of 3D geometric process. We're really thinking more about data and the management of data and the organization of data and how we use it to our best advantage as a professional to make sure that we're actually showing the right information at the right time, etc. So what I've done is I've broken this presentation down into looking at the RIBA work stages, and in each stage I've got a little summary slide like this one, which will actually tell you the type of things that we're thinking about at each stage, and then I go into a bit of detail about some of the topics. So at stage 0, the strategic definition, really it's quite light from a sort of deliverables point of view. We're more hoovering up information from others, so trying to get the initial employer's requirements, trying to define what sort of technology they're using, what their vision is, what their aspirations are, trying to get down to the nitty-gritty about sort of their strategy and the basic principles of how they see BIM working. So it's really about scene setting. It's about gathering that information and understanding what the project needs. Then when we move on to stage 1, we start to get into a little bit more detail. So we look at standards, we compile the project information requirements, we review the project information requirements, we produce capability statements to demonstrate how we've done things well in the past and what we're going to do on the project. And that links through really well into things like appointments and our design's responsibility matrix and so on and so forth. So taking those one at a time, we've got an absolute massive industry standards. ISO 19650 has come out now and is an established standard. We've got the national annexes, and you can see that we've got a whole suite of information across the bottom of the screen here of the type of documents that we would refer to try and actually make sure that the project team was as up to date as possible. Now, as part of these things, we would review all the different types of information exchanges that we're likely to do over the periods. We'd start thinking about KPIs and really linking all this documentation together. So in terms of the project information requirements, I'm holding up the Manchester Metropolitan University client as quite an exemplar clients in this instance. What they've tended to do is they've got together a suite of information, and they developed the suite of information under PAS 1192. So you can see that some of the titles are using the old terminology, but fundamentally, when they read all of these things together, it gives you a good chunk of information requirements that they need. It tells you how to classify information, how to name rooms, how to name facilities, how to name buildings, etc. And they've thought really carefully about the key information that they need to run their large estate, and they're really understanding the benefits of this this type of process. And one of the key things in stage one is for us to actually make sure that the information we're producing for them is relevant and will help them in the future, because there's a sort of fear always, isn't there, that you tend to get a very detailed set of requirements that will take a long time to produce, and then nobody will ever use them. Whereas this set of information is very clear, and it's boiling down to what they need. In terms of capability statements, then we have a series of accreditations as BDP as an organisation. So we're externally audited. I mean, as you can see from the certificate here, this is to 1192, but it's an external organisation who comes in and actually looks at our processes to sort of demonstrate our compliance with the standards, which is things that the clients are very keen to see. Designers' responsibility matrices are really important, and although these are live documents that sort of develop as the scheme develops in detail, we've got a couple of things that we can rely on. The RIBA do a really good schedule that you can use, focusing very much on the architectural stages of 2 to 4. We tend to find that, although this is a really good example, it follows the Unicast system. And what we prefer to do as BDP is we prefer to actually align our appointments and our designers' responsibility matrices so that they follow. So, for example, if we had 25 tasks in our appointment, we would then actually have 25 tasks in our responsibility matrix here. We'd go through and we'd identify who the primary responsibility was. Even for the management items, it might not actually produce a BIM deliverable, but it's still listed as who the primary responsibility is. And then it goes through the level of detail and level of definition, etc., that we'd expect. One of the key things that we've added to this as well is a sort of contributory input column. Now, that's all about trying to make sure that we're creating links between the various professionals. So although the structural engineer might be responsible for the structure, the architect will contribute in the sense that we will actually try to help them coordinate and set out the structure to suit the project developments, etc. One of the things we like to set up at this stage as well is a series of key performance indicators. Now, what these are doing, we get the design team together and we try to agree a number, in this instance, there were 5 things that we decided to review. And we'd sort of set these up to try and establish the general health of our BIM information. And I'll talk about the importance of why we do this a little bit further on in the presentation. But the key thing for this is it's got to be quantifiable, it's got to be reasonable, and it's got to be measurable. So you can actually track with the design team progress, positive or negative, across the whole process. And we agree that as a design team, and you say, look, this is how we're going to judge ourselves through in the design process. So when we move to RIBA Stage 2, we're really adding flesh to the bones on the DRM. We're establishing tools, we're developing BEPS, we're reviewing things like appropriate common data environments. We're trying to create a single source of the truth wherever possible, and really starting to look at the survey in a little bit of detail. And depending on the client, sometimes the survey comes earlier, sometimes the survey comes later, but the general principles are the same throughout. So in terms of sort of setting the scene, we use the MBS BIM toolkit quite a lot, because the amount of documentation on this website is very clear, and it helps people who aren't necessarily designers understand what the difference is between a concept model and a final construction model. So when we're trying to set out an appropriate level of geometric information, for example, we can refer to this and say, look, this is an industry standard, this is something that we would expect to do, and this would be something we expect our competitors to do, this is what we're expecting from the supply chain, and so on and so forth. So it gives us something that we can rely on quite well. We also establish the tools. Now, as BDP architects, we tend to use these 3 tools, and we think of each tool as a database. And one of the key messages for information is to try and make some way of easily transferring between the Revit database, which is geometric information, the Chorus database, which is specification and notation databases, and then Derofus, which is something that we use for gathering room data and briefing information as well. So the systems that we put in place for managing information are trying to enable the users, i.e. the architects, to actually understand which bits of information links to the other bits of information in the different programs. Our BIM execution plan then is starting to develop at this point. So we're taking on board all of the client's requirements and all the design team's agreements, and we're documenting it. So the key thing about this is it's live. So as we sort of tweak our processes to suit the requirements of the project, we're making sure that this is updated so that everybody knows where we stand. It's simple language. It's saying what we are doing. It's saying which bits we've decided not to do, which is also quite important. And it's something which everybody feeds into, even though the sort of BIM coordinator type people in the organizations tend to deal with the detail of it. Common data environments are quite key as well. So I kind of like these tools because they're auditable, they're trackable. We have to set them up very carefully. So when we talk about workflows, and especially when we're talking about a formal approval process, we have to be incredibly careful. So the ones that we tend to get involved with quite a bit are ProjectWise, A-Site, Autodesk BIM 360, and Viewpoint for Projects. So those tend to be the general tools that we end up using. And the access rights and the workflows are all the sort of things that we set up, and we try to make them bespoke for each project so that they actually suit how the client wants to work. This key principle at stage 2 about having one source of the truth is really important. So even from a very early stage, as you can see from this screen grab here, we're trying to make sure that all of the documentation is coming from either the model, or it's coming from the specification, or it's coming from the room data sheet. And we're trying to just say it once and say it very clearly. This is one of our sort of real life examples. So here I'm going to break away from the sort of stage 1, 2, 3, 4 and actually just take you through the whole life of this particular project. So we've developed a sort of scope for measured surveys and point clouds, and it's quite key to agree certain things like the shared coordinate system, how it's being delivered, defining the accuracies that you want, and also if you're converting a survey, a point cloud survey, into a Revit model, what type of geometrical accuracy you actually want the surveying company to achieve. So you can see here this particular example is from Oldham Town Hall. So this is the raw output of the point cloud data. And then for Oldham Town Hall, the survey came to validate the design model that we'd created. So your design model fits over the top of it, and then we did an assessment about sort of key interfaces. This was an existing building, it was grade listed, it was very intricate, it was very ornate facades, etc. So what we did is we sort of validated the very basic shell was correct and the sizes were correct, and then we started looking in a lot of detail about key interfaces. And you can see as the model has developed that actually we started to color code the different window types. So condition of the windows and so on was recorded in the model. And the model then started to generate things like the conservation architect's repair reports, etc. that they needed to put together. That model was then used also for visualizations. So it was, again, the live design model was the actual visualization model as well. And there's the final project completed in 2016, 2017, and it was an RIBA regional award winner as well. So we're quite proud of that one. So then going back to the sort of outputs at the various stages, stage 3 is where we start to think about regular swapping of information between the various disciplines. We're starting to concentrate a lot more of how the data is organized, progressing the model, starting to write specifications, and then starting to share information. So this is a typical BDP sort of process where we would look over a sort of 2-week cycle. We'd be compiling everybody's models, we'd be clash detecting, we'd be looking at holding meetings to resolve clashes, we'd be getting the designers then to update the models, and then we'd be sort of sending them right back to go back through the process in a circular manner. In terms of organizing the data, although one of the key things is Unicast 2015, and that tends to underpin a whole load of our information, what we've tended to find is that the users need some system to enable themselves to easily match things like specification clauses to actual geometric objects in the Revit model. The Unicast codes do change around a little bit, so we've tried to actually not use that system. But instead what we've done is we've created a 3-letter followed by a 3-digit code. And I think a number of large projects in the industry actually use something very similar to this. And it actually just helps us sort of boil it down a little bit. I'll give you an example of that for internal wall partitioning systems. So our T-sheet, our tag sheet, defines things. So for example, BAL would be referred to balustrades, and therefore the families would be named BAL and so on and so forth. And that they would replace the types that you would use traditionally, like type A, type B, type C. So for the partition, you've got something from the T-sheet which would give you the code. Then in the background, that would be linked to the classification, which was the Unicast 2015 classification. And then the output would enable you to tell you what the type was, give you a basic description, and then also append the designer's responsibility to the end of it as well. And you can take this quite far if you want to. You can actually break things down as detailed or not as you need. So in this example here, what we've done is we've actually suggested that there are 3 different wall types. One's fundamentally a standard partition, one's an acoustic, and one's a fire. So we've linked systems to the specification so that the actual wall properties are recorded. And then we've broken down each one of the layers so that of the system in Revit, so that links through as well. So all of our notation can be driven from this model and from the spec. We start to develop at this stage the outline specifications, and this is where all of the architects are inputting into the process. They're all putting in the key things that they know about what they're drawing into the spec as they're going along and developing the detail. So for example, at this stage, it might be very simple. We might say that this curtain walling system is anodized aluminium and it's gold, and that might be as the first bit of information that we put in. And then as we develop, somebody will come along and add more flesh to the bones. But by getting the designer, the drawer, to give it a tag, to think about its key properties, and to record those key properties, we're actually making the process quite efficient. I'm quite a fan of these web viewers that are developed as well. So for the BIM toolkit, for example, you can upload IFC models, and you can actually then give clients access to the actual information. So these type of things are really invaluable, because I, as an architect, sit here with very expensive software, very powerful computers, and I can view all this information very easily. With this tool, you can actually give it to everybody, and they can use relatively low quality machinery. And as long as they've got a good internet connection, and as long as they've got a web viewer, they can actually start to understand the design information that you're putting forwards. In stage 3, this is where our key performance indicators come into their own. So you can see this is an example here where we're talking about model warnings. And you see we can start off quite high. So we're genuinely trying to avoid this type of situation and actually start to bring the errors down. And you can see in this example, we dropped them pretty dramatically. We're looking out for these odd little peaks. So in between the 2 periods, for some reason, the actual model warnings had dramatically increased, and you can see it drops off again at the next reporting period as well. And this is what the key performance indicators help us to try and track. They're giving us a general health of the model, and they're also highlighting where things might have gone a bit wrong. Now, as the RIBA stages move forward, we'd expect a general increase of sort of things like model warnings and so on and so forth, because actually, as more details put into models, you'd expect the sort of errors to creep up slightly. But it's trying to level out and ignore those peaks, and that's the key thing. So then when we get into RIBA stage 4, we're starting to really develop the final bits of geometric information and specification information, and bringing those up in incremental small steps to the end of stage. We invest a lot of time and effort in auditing, and we've got automated auditing and manual auditing, and then also we've got COBie information to talk about as well. So in terms of basic 3D geometry, this example here is again from Oldham Town Hall, and this shows you what the base 3D geometry looks like, and then actually how we've augmented it with other 2D families, which are still linked and they're named correctly, and they're linked through to specifications, and the notation is all centrally managed, etc. but actually it adds that next level of information over the base 3D geometry. And the key thing is we're always linking everything together so that the information is, when seen together, is acting as that one source of the truth. This is one of the key benefits that we really see at the moment. So when we've done our 3D model and we've got the geometry correct and we've augmented it with 2D objects, etc. as well, each one of those objects, systems, families is all linked through to specifications. So actually it pulls from the specification, the Unicast code, the T-sheet tag, the description, and the designer's responsibility. And then we can put it on the drawings. And this gives us a bit of reassurance that fundamentally every drawing is consistent. And as long as we've spent time thinking about how the data is structured, then actually we can be pretty confident of the end result, and it helps reduce those little errors. Auditing is getting more sophisticated as we go through. So we've developed a BDP BIM health check report. We color code everything with a traffic light system. So red is we've got a serious problem. Amber is, well, it's not very good, but let's see if we can improve it. And then green is, yes, you've done a good job here, and this is what we'd expect. And a lot of these are becoming automated, so it's helping us use data that's in the models to actually give us an idea about where we can focus our improvements. The auditing tools also use that idea of big data to actually try and sort of visualize for the users. So this auditing tool is particularly talking about families. It's talking about how many of each family you've got. And you can see here that we've got a lot of detail items in this particular model. We've got a lot of plumbing fixtures and so on and so forth. So if we were going to go for any incremental improvements, we can see where it is we should focus our attention. Kobe. This is one of the most demanding parts of the information requirements for projects. It takes a bit of time and care and effort to make sure this is right. I think this is going right back to the initial principles where I was talking about making sure that the client understands what they're going to get and defining what they want. So using the MMU, Manchester Metropolitan University example, they know what they want and they have limited their information requirements to just what they need to maintain their estate. That's great. That's the type of conversation we need to make sure that everybody's having. Because if you ask for everything, you could spend months compiling information that's never used, and actually by focusing your information requirements, you can actually zoom in on things which will benefit the client in the future. Stage 5 is very much about the manufacture and construction. So this is where, as architects, we tend to have a lesser role. But the next project example I've got is from the Ordsall Cord, which is a network rail project, where we really took the BIM and information and modelling requirements right the way through the process. So this process was led by the contractor, stage 5, it's as you'd expect. We had some really good input from AECOM and McDonald's, who were the engineers for it. And they created this structural model of the bridge, which had quite a lot of information attached to it. This modeling enabled them to reduce the amount of 2D drawings that they produced. So they took the model and then, using technology within the fabrication yard, were able to use computers, laser scanners to set out the fixtures, fittings, connections very accurately on site. So to put it into scale, this is a 94-meter long bridge. That's an idea of how big it is on an articulated lorry. That's just one of the connections, or two of the connections on the back of an articulated lorry. And this is it being lifted into place. So a 94-meter bridge. Two of the largest cranes in Europe were actually installing this. And using our digital technology with surveying, point clouds, etc., 3 of these nodes went in perfectly, and the 4th one was 10 millimeters out. So over a 94-meter length, to get within 10 millimeter accuracy is an absolute cracking success story, and it's absolutely brilliant. And again, we were glad that this was a national award winner in 2019. In terms of the final stage, stage 7, we've really got quite limited information. In terms of stage 7, we've got very limited input, really. We tend to do very light post-occupancy surveys, but really now it's a case of the client's got all of their information, we've given them what they've asked for, hopefully, and then they take this on and they develop it ready for their next project. So that takes us through all the way through the various RIBA work stages and tries to give you a flavour of how BDP organise the data, how they approach talking to clients, and what they deliver at the end of it. Thank you very much.
So thank you very much, Mike. Now we'll move on to Chris Vickers, MBS. Chris.
Many thanks, Stephen. As a brief introduction to myself, I previously worked at Faulkner Brown's Architects as an architectural technologist, where I predominantly worked on educational projects ranging from £10 to £25 million. Early in my career, I worked with traditional 2D CAD, but we were also some of the early adopters in the transition across to information modelling. It was very clear to me during these early stages there was a need for manufacturers to work closer with the industry in its new digital approach. I've now taken all that knowledge to help our customers embrace digital technology, with the goal to strengthen relationships between manufacturers and designers across the built environment in digital construction. My presentation will look at how MBS brings people, organisations and data together. Let's begin to look at why a standardised approach to information is important. As a consumer of goods, we live in a world that's defined by standards without really giving it too much thought. A USB charger is a great example and was a result of a new European directive aimed at reducing e-waste and replacement costs for consumers. Good standards address a need or problem and provide clear specification requirements. Removing 51,000 tonnes of e-waste every year can only be a good thing, not to mention no longer having to pack 2 or 3 different chargers on every journey. The construction industry is of course no different, and as a consumer of goods in the masses. If the same standard is used across the same sector, it's of benefit to all stakeholders. Historically, vast amounts of information is created and wasted during the construction phase of a project, so approaching this in a more structured way allows data to be managed, compared and analysed digitally. In doing so, it provides much more transparency, which is a key driver for the industry moving forward. However, standardisation shouldn't stifle quality of information, with many consumer products exceeding requirements and offering enhanced levels of performance. This information should be captured, and we'll touch upon this later in the presentation. So why is classification important? Well, first of all, classification provides a common language for people constructing and managing assets. There are many ways to name and describe something, but at the end of the day, a carrot is still a carrot. It also identifies all things and labels them consistently. It enables the ability to search and retrieve information from a database or an asset register, etc. It also enables related information to be grouped for the purposes of measurement, estimation, purchasing or reporting. So how did we get to where we are today? So the industry has used Common Arrangement of Work sections, or CAWS, for many years, originating back in 1987. It established a consistent structure for specification and bills of quantities, and its development was a result of research that demonstrated quality of information was a very significant factor in the quality of on-site construction. 1997 seen the first Unicast edition released to better accommodate the entire design team and not just architecture and landscape. CAWS itself became one of the 15 tables, as it was seen as best in class within the industry. So all CAWS work sections are further subclassified and offer information and supplementary guidance. However, they are generally relevant to one main trade. If we take a suspended ceiling system as an example, it can be seen that the products such as the plasterboard sit within section K10. However, products to cover the framing or the insulation or the fire stopping are covered in other work sections. An early initiative in 2011 looked into Unicast 2 and how to unify a common coding across all tables, and it was also an opportunity to remove repetition across different sectors. However, it wasn't until 2015 that a unified classification system for the entire construction industry was developed on behalf of the UK government. The suite of 12 tables is based upon a hierarchy and allows information about a project to be defined from the broadest view to the most detailed. Complexes which provide the activity describe projects in overall terms, and can be further subdivided into entities and spaces. All of these are broadly based around industry, sector and function. For detailed design and construction, the main starting point is entities. These are subdivided into elements, functions, systems and products, and are broadly arranged by fabric and function. So to give this some context, on this holiday complex we have a sports building entity, a beach and outdoor play location. But then if we drill down into the dining entity in more detail, we can see that this is subdivided into multiple spaces. If we drill down into the public toilet space itself, this is defined by elements, which are the main building components, such as the wall. The wall is built up of systems, such as a rain screen cladding system, which in turn is then built up of products such as the PIR foam board insulation. Let's now look beyond the classification groupings and interrogate systems and products in more detail. Each specification section within the MBS content is clearly structured to help you work your way through the clauses and capture requirements relating to different topics and project stages. System outlines provide a clear overview of a system or set of systems such as ceilings, flooring, heating, or framing. This is also a generator clause to bring the products and execution clauses you need into your spec. System performance clauses record the performance requirements of each system, for example, fire, acoustic, thermal, or durability. Product clauses detail the products, components, and accessories that make up the system when put together. Execution clauses detail the execution and workmanship relating to the construction and installation of systems and their products, along with testing and checking. And system completion clauses detail the final requirements needed to complete the work, for example, verification or cleaning. All of these additional clauses or requirements are structured to Unicast 2015. Now let's interrogate system outlines further. Although all the technical sections follow the same logic, system outlines do differ according to sector. This is due to the nature of the systems and products specified. If we break down the suspending ceiling components in more detail, architectural outlines generally follow a layered approach from top to bottom. In the system outline, we already have acoustic performance requirements. We start with the structural element and then build up the system as we move down, mirroring the system construction sequence on site until complete. So we start with the suspension grid, we move on to the fasteners, the acoustic insulation, and then finally the board or face layer. MEP clauses work on an input or source required to achieve a particular output. In this very simplistic example, we start with an electric boiler. Include all the distribution system component parts, such as a pump to increase the system pressure, the pipework, radiator valves, and then we finally finish with the output, in which in this instance are the radiators themselves. Both approaches allow designers to consider the full potential products by using the system outline clause to ensure that no product is overlooked. Those interrogating a specification in this format can understand the full construction without the need to jump between different sections as seen in the previous cause example. Of course, product manufacturers are integral to the spec process. The structure of a manufactured product clause always includes a product description explaining what it is, who manufactures or supplies the product, reference to standards according to a region, such as British standards, and third-party approval where applicable, such as a BBA certificate. However, we do need to be mindful of regional variances. Unicast 2015 is based on ISO 2006 Part 2, which is a consistent international standard for classifications about construction anywhere in the world. The consistent numbering allows for easy translation around the globe as seen in the clay brick example. If my Japanese is up to scratch, that says Nendo Renga. Over 60 countries now use Unicast 2015 on some projects, with its adoption included in digital strategies across the globe, such as the transport for New South Wales and Australia. However, even though the unified coding allows for global usage, the terminology and requirements within each technical section structure will always differ. We can see that we're looking at the clay brick section, with the UK on the left and Australia on the right. The standards across both sections are specific for those regions, as seen by the default standards referenced. Within the UK clay brick section, we have a dimensional deviation clause named mean value, with expected inputs according to the British standard in the drop-down list. In the Australian section, this is named dimensional deviation, and you can see the differences in expected values. Both mean the same thing, but the sections have been authored by MBS technical authors to accommodate these regional differences. So let's discuss manufactured products in more detail. Manufactured products in MBS source are now aligned to the MBS system or product outline specification clauses utilising Unicast 2015. This is referred to as enhanced data as it's structured to meet requirements of the specifier. These improvements are the result of feedback that we've received from construction professionals over recent years, which included focus groups, surveys and general conversations. All were unanimous in the need for more quality data. If we draw comparison from the development of CORE's classification where it's proven that quality information equals quality on-site construction, this is really the next enhancement to the development of specification. Enhancing the data has many benefits. As you can see, this is the hand dry example. The enhanced data in MBS source is shown on the right and it's replicated in the MBS chorus to the left, allowing for a much more seamless transition into the written specification at the click of a button. I've previously mentioned standardization shouldn't stifle quality of information, with many consumer products exceeding requirements and offering enhanced levels of performance. Therefore, this information is also captured as supplementary data. It's not just about the structure of the information, it's also about trust. If we take a look at a typical product page in more detail, we have permanent URLs to access the product page at a later date. We have an indication how recently information was confirmed as up to date by the manufacturer. An elevated importance to third-party certification, confirming performance, and to which testing standard. Providing this information is also reinforced by the recommendations made by Judith Hackett's report, Building a Safer Future. Also, what applications the product is suitable for. Is it designed to be installed in the roof or ceiling void, for example? And then finally, as MBS source uses an MBS ID, we can access historic project data to understand previous usage and if the project team or client were satisfied. All products also have a minimum standard property set to allow for basic filtering and comparing across different manufacturers' products. These properties were compiled from feedback from our focus groups, surveys and general conversations during the development of MBS source. In this example, we have searched for paint and then narrow down the results by selecting a gloss finish. These are further supplemented by the inclusion of standard environmental information. Responsible for almost 40% of global carbon emissions, the built environment must adapt to combat climate change. There are various initiatives already in place, such as the RIBA developing their 2030 climate challenge, but MBS source has given us an excellent opportunity to try and request and publish more sustainability information from our manufacturers. Again, through consultation, the consensus was to include 6 standard properties, but we can list additional specific properties and third-party certification where applicable. Of course, digital objects, either generic or proprietary, are an essential component during design or asset management, and the principles of standardization, classification, and specification are at its core. Split into 5 sections, the BIM Object Standard looks at the standardized approach to digital object creation as a minimum requirement. I just want to spend some time highlighting a few key areas using the digital boiler object from our previous slides. All digital objects include Unicast 2015 classification, so we have the ability to link digital objects to the specification through consistent classification in the MBS portfolio. The UK National Annex to BS-EN ISO 19650 Part 2 lists Unicast 2015 as the required classification system for work in the UK. Inclusion of enhanced data structures mirror the system or product outline structures as shown previously, with supplementary data included where applicable. For digital objects used in a system, consideration must be given to how these are associated with other objects in the model. So does the object need to include pipe connections, for example? Does a clearance zone need to be included for the purposes of coordination? Or does it need to have the ability to flex in size? All functionality needs to be considered before object creation starts. As well as a standard naming approach documented in the standard, there are a few tools MBS have shared with the industry to address consistent naming and terminology. The first is the free access to the Revit shared parameter file, with all the general, enhanced data, IFC and COBE properties included. We've also developed Revit project and family template files for those who create in-house content, with all the minimum requirements already pre-populated. Lastly, there are BIM software plugins available for ArchiCAD and Revit that allow downloading of digital objects or access the MBS Chorus, our cloud-based specification software. We now have the ability to write or view specification at the same time of placing objects within a model, removing previous siloed processes. The digital objects and tools we provide need to consider any regional differences, so the BIM object standard is being written in a way that it can be adopted across the globe. This heat map illustrates global traffic at a given time of day and will obviously vary according to time zone. I appreciate I've covered quite a lot already, but to conclude, our roots lie in the UK's National Building Specification, for which for nearly 50 years has been helping the construction industry build better and with lower risk. Our future lies in cloud-based technologies and connected data, as we fast become the information platform for the global construction industry. Classification in particular is updated every quarter. The updates depend on who we're really working with at any one time, with recent examples being UK Government, Highway England, the Environment Agency and the MOD. We believe the industry can better deliver outcomes by bringing people, organisations and data together through technology and smarter ways of working. Working digitally to a standard process will help us achieve this.
Thank you very much, Chris. Okay, now we'll move to a little Q&A section. Now, so starting with yourself, Mike, thank you very much for the presentation earlier. I was just wondering, on a large project like one of the ones you showed in the presentation, roughly how many have you got at BDP on the design team, and how many of those in the team contribute to the specification writing?
It's a really good question. That I think everybody in our design teams contributes to the spec writing in a small way or a larger way. What we tend to find is obviously you're going to have different levels of experience throughout the team. So we're not all going to be sort of wise heads which actually know how things go together. There's a wide variety of skills in the team. But on a very basic level, everybody gets involved in typifying and picking the codes from the master T-sheet that we've created and actually structuring their information as they're drawing. So we'll find that of the team, everybody gets involved in establishing the T-sheet and the master T-sheet and the project T-sheet. And then what we tend to do is we tend to make one or two people, depending on the size of the project, who are then responsible for taking the basic information that they've produced and applying BDP standards, thinking about things like workmanship and execution and so on and so forth, and then actually fleshing out the major detail. And it tends to be the more experienced members of staff then who start looking at, details of British standards and performance requirements, etc. But on a very basic level, everybody gets involved in it.
Oh, very interesting. And your examples today were mainly architecture examples, but do you have a similar process, or are you trying to introduce a similar process for landscape, structure, MEP?
Yes, we are. Yeah. So what we do is the architecture profession actually have sort of led this in BDP, and we've sort of been going through the process of trying to prove that it works, demonstrate business benefits, etc. Now that we've started to get that ingrained into the architectural profession, where all of our other professions are also taking an interest in how we work. They're looking for parallels, because actually we don't work in exactly the same way across professions, but they're seeing that there are some things that they can steal from the process and make their own workflows better. So particularly landscape and structure, they're actually looking at this very, very seriously now and trying to actually create a whole suite of sort of standard documents as well to build on what we've already produced. And we're doing really well, I think, with that. It's really good from a multi-profession, multi-discipline practice like BDP to actually try and make sure that we're as consistent as possible across all of them.
And at the start of the presentation, when you mentioned BIM tools, and you talked about the likes of Chorus, and I think Derofis was the other tool where you're putting information into the cloud, but connecting it to a 3D model and then tool like Revit. Where do you get that balance between what goes in each database?
Yeah, that's a really good question. I think it does vary from project to project, but what we tend to find is we want to put so much information into the various design models that we're creating that if we were to just pick one of the tools, it would become instantly overloaded. So we're trying to make sure that we put the right information in the right tool. So for example, geometric information in Revit is the obvious place for it to go. And then when you start to put type information, well, you think, well, you know, I could typify things in Revit, and I could use type marks and so on and so forth as the standard parameters that come out of the system. Or I can actually start to pull that information out of Chorus, because actually we've already used that. And in the examples I've shown you today, it's all been in the prefix in Chorus. So we can then get Chorus to start driving our type in Revit so that the notation, etc., follows through correctly. One of the things we've noticed is that actually we have to be quite careful about things like naming of families and naming of family types to make sure that the person who's drawing actually understands the structure that we've put into place. And I think the benefit that we've found this gives us is that it actually lightens some of the Revit models. So rather than you sort of working on an 800 megabyte file, you're suddenly working on a 400 megabyte file, which is a dramatic improvement in the performance. So it means that people are actually able to work a little bit quicker, a little bit more effectively, and that's the real benefit. And it's the same with things like DeRofus as well, because actually with DeRofus information, we can actually put briefing information into that database, and it doesn't therefore have to be held within the room within Revit. So it just lightens up the room within Revit and actually makes the performance a little bit better. Also, and helps you do things like, you know, room data sheets and so on and so forth a little bit more efficiently and effectively, along with all the auditing benefits, etc., of using that bit of software.
Now, in terms of setting up the planning sheet, I think you call it the T sheet. Did you plan how it's broken down into packages and what's descriptive and prescriptive prior to the main contractor coming on board? Do you sort of have an idea of where things fit, or like tell me how that happens in the timeline?
Yeah, so at the early stages, we like you've alluded to there, we have a sort of standard document which sort of says what our suggestion should be for each one of the packages. So we've been through and we've sort of looked at how we'd expect the process to work normally, and it tends to be heavily weighted by design and build contracts, if I'm honest, where we sort of assuming that sort of post stage 3 we're starting to get a lot of contractor involvement. So we've set up our sort of standard on that basis, but I think it is just a suggestion. It's something that we've looked at and said, look, we've created this suite of documents on the basis that this is descriptive and that is prescriptive and so on and so forth. But then when we get an appointment document through, then a lot of clients actually have their own requirements. So actually a lot of this is then about saying, well, there's our standard, that's what we're being asked for. And there's usually a middle ground between the two. I mean, there are some, you know, very obvious ones that it's very difficult for us to take full prescriptive responsibility for. So, for example, curtain walling, you know, I think we'd always expect a sort of specialist to get involved to complete the design. Whereas something like masonry, you know, yes, it can be more prescriptive, and the architect can take responsibility for how the whole system goes together with inputs as appropriate from structural engineers and the like, so on and so forth. So I think the examples that we put in the sort of template documents, for want of a better word, are actually pretty well defined. But they do tweak slightly.
Okay, that's fantastic. Thanks, Mike. Well, I'll move on to 4 questions to Chris now. Okay, Chris, a few questions for yourself. Number 1, for Unicast 2015. The name 2015, does this mean that it hasn't had any enhancements for 5 years?
I think the first thing to say there is don't confuse the naming of the classification system with how up to date it actually is. The tables are still maintained. We actually update every quarter and have done since its inception. So we update every January, April, July and October. I mentioned a few organisations in my presentation who we're currently working with or have done previously, and these really allow us to review the existing tables and update or add new clauses where we think it's necessary. An interesting example actually that's just came to mind is we've been talking to a team working on the refurbishment of Houses of Parliament. So they are really interested in how we connect the tables with heritage items on the asset register. So all interesting stuff, and it's all contributing to the overall development of the tables. Unicast 2015 is also very responsive, so it has been developed to allow it to adapt to different needs and different sectors, and we will continue to see this grow and develop going forward.
Yeah, thanks, Chris. Are most of the industry now using Unicast 2015?
I think our current stats show it's around a 50-50 split now with CORS and Unicast. So Unicast has quickly caught up with CORS classification, and I think this is probably down to two reasons. The first one being which procurement route is taken. So the more traditional, typical larger tender specification is still quite often delivered with CORS classification. But with the growth of contractor-led design and build, these actually tend to be more descriptive specifications. So Unicast 2015 is much more flexible in that approach. The second reason I think is BIM, and it's probably following industry trend really. So Unicast allows much more of a linkage with digital objects. So what I mean by that is the data structures are much broader, so we can link back to systems and products, for example. For BIM projects, we see Unicast 2015 being utilised more often. This, of course, is reinforced as well with the ISO 19650 series documents, which I touch upon it in my presentation as well. So the UK Annex stipulating the use of Unicast 2015 as its classification as well is all contributing to this. It's probably worth noting as well that CORS is actually no longer maintained as a classification system. So again, this is undoubtedly playing a part in its adoption too. And just to finish, it's also worth noting that regardless of which procurement route your projects do take, MBS CORS can actually accommodate both classification systems. So if you work across different projects in the office, this isn't really a barrier.
And then finally, Chris, what digital information do manufacturers need to provide now to the industry?
So I think there's probably two elements to this question. The first one being the data perspective or the specification. We would typically request product data sheets, but there are instances previously where manufacturers actually don't record all of this information that we require. So we would then request additional information such as declaration of performance, testing reports or certificates, and that's really just to capture all that meaningful information that our end users want and need. I would probably say that's the minimum requirement. In addition to that, we also capture safety and environmental data, which I ran through previously, and all of this is really just to install that confidence element. So ensuring information is up to date, we have access to third-party approval certificates, and we provide guidance on product or system application, for example. The second part of this is digital objects, where we need to consider the 3D geometry. So from a data perspective, it follows the same approach as specification. It's this single source of truth we now use on MBS source. But for the 3D geometry, we do typically request DWGs, either in 2D or 3D, but we can also accept SolidWorks or Inventor files too. So these two file formats do need a little bit of manipulation prior to export, but we can use those file types too. We have and can use PDFs or dimension PDFs for the more sort of simple products, but we do review them on a sort of one-to-one basis and confirm that we can use that information.
Okay, just a little bit off me to wrap up. If you want to download the RIBA Plan of Work, search it in Google, you'll land on the architecture.com website, and it's a free download here, as is the overview document, about 150 pages long, really good, and the toolbox that includes the design responsibility matrix that Mike mentioned. Hopefully you already know about MBS, but two main web platforms: MBS Chorus for specification, MBS Source for manufacturer's information. So just briefly, you can create a specification here, common arrangement of work sections, or Unicast 2015. And then just wanted to quickly demonstrate what Mike was illustrating in some of his screenshots, and that's that, I think, balustrade and guarding system he used in this example, but you add your specification into the main spec there. And then in terms of those 3 or 4 parameters that were shared with the Revit objects, you can have a prefix, which I think BDP has something like that, like balustrade type 1. And then if that was going to be prescriptive, I think that's a little dash P at the start. And then those 4 little codes at the top will be shared with the digital objects, and you can slowly go through and develop the spec through the timeline, either in terms of its overall performance, the products that make it up, workmanship, system completion. And in parallel with the spec, which has got all the generic templates, you've got MBS source, source.thembs.com, and everything in source is now classified by Unicast 2015 as well. So as you start to type here, these categories are using the terminology from Unicast 2015. So I could quickly go and find a composite window unit that has digital objects, maybe secure by design certificate from the manufacturer of LFAC, and you can see the content, you can compare it, and it's a modern web platform with really nicely well structured technical content there. You see you've got third-party certification, spec data, download digital objects, a little bit of guidance on what it's applicable to, and then jumping across you can see all the products from that particular manufacturer. Again, all classified, Unicast 2015, certification, case studies, installation manuals, etc. And that's all free to use by end users, source.thembs.com. So yeah, one last final reminder, all of the previous webinars on key topics in the RIBA Plan of Work, like sustainability, fire safety, inclusive design, health and safety, are available to watch on demand now on our website, mbs.com/events. If you'd like to know more about MBS, get in touch, pop a little comment in any feedback in the comments window is always really appreciated. Visit architecture.com, visit thembs.com and drop any questions through, or give us a ring, drop us an email. Thanks everybody, and bye-bye.